Artificial womb helps premature lamb fetuses grow for 4 weeks. Extremely premature lambs have been kept alive in an artificial uterus for 4 weeks. The system uses a fluid-filled plastic bag and could be used for premature babies within the next 3 years. We've developed a system that, as closely as possible, reproduces the environment of the womb and replaces the function of the placenta, says Alan Flake at the Children's Hospital of Philadelphia in Pennsylvania, who led the study. It is fascinating, says Neil Marlowe at the University College London. People have been trying to do this for ages, but he says the system will have to undergo years of testing to be sure it is safe for babies. Flake and his colleagues developed their system with babies in mind. Being born extremely prematurely is the most common cause of death in babies. Infants born at 22 to 24 weeks instead of a full 40 weeks have only a 10% chance of survival, says Flake. Those that survive are vulnerable to a host of disorders and can develop lasting disabilities, such as poor vision or hearing or cerebral palsy. They have very immature organs, says Flake. They're simply not ready to be born yet. Babies supported in incubators are prone to infections, for instance, and the gas ventilation that is needed to help babies breathe can leave them with lung damage. But the plastic bag system provides a sealed environment that should protect a fetus from infections. To mimic the environment of the uterus, the team filled their bags with fluid comprising water and salts. In place of a placenta, which supplies a healthy fetus with oxygen and other substances, the team connected oxygenator devices to the umbilical cords of the developing lambs. Instead of pumping oxygen into the lambs, the team developed a technique that uses the animal's own heartbeats to drive the collection of oxygen from the device. They hoped that providing oxygen in this way would be better than the ventilators currently used for premature babies, which can damage their lungs. In their experiments, the team used lambs that were between 15 and 17 weeks into the full 21-week gestational period for sheep. These were removed by cesarean section, carefully placed into the bags, connected to the oxygenators, and then closely monitored. The lambs were kept in bags for up to 4 weeks. Most of them were then euthanized and examined. All of the lambs appeared to show healthy development, and the team found no abnormalities in the lambs' brains and lungs. These animals are, by any parameter we've measured, normal, says Flake. Some of the lambs were born, removed from the bags, and bottle weaned. The oldest is now a year old and is doing well, say the team. They are now working with the U.S. Food and Drug Administration to develop a version of the device for extremely premature human infants. Their plan is to support babies born at around 24 weeks until they've reached around 28 weeks. By this point, their odds of survival are much higher, says the team. This is a very reasonable plan, says Mark Turner at the University of Liverpool, UK. However, Turner is cautious of the team's aim to trial the device on babies within 3 to 5 years. I have concerns about getting the details just right, says Turner. Some treatments for premature babies have previously been rushed through, only for it to be discovered later that they are harmful. In the 1960s, for instance, babies were given too much oxygen. This disrupted the formation of blood vessels, in some cases causing the retina to be separated from the back of the eye. Several thousand children went blind because of that, including Stevie Wonder, says Turner. If the team can get the system working for human infants, it could be useful for only about half of the babies that are born extremely prematurely, those that can be delivered by C-section. For their human device, Flake's team hope to improve the fluid that babies will be bathed in. Amniotic fluid contains nutrients and growth factors as well as fetal urine. The team plan on adding substances that are known to aid the development of the gut, for instance. The human device will look different too. I don't want this to be visualized as fetuses hanging on the wall in bags, says Flake. He says the device will eventually look like an incubator, with a cover and a dark interior. He also plans to make the device parent-friendly, allowing parents to communicate sounds to the baby and see it with a camera. Marlowe says this is an important consideration as having a premature infant can be extremely distressing for parents. On the whole, Marlowe is optimistic about the device and shares similar concerns to Turner. Anything that is more gentle and interferes in normal development as little as possible is to be welcomed, says Marlowe, but we need to keep an eye on the risks.